A very good morning to all. Welcome to science class. In the previous lecture, we have studied about distance, displacement, speed, and velocity. Now, here we will see how the units of speed and velocity are measured and how we get the unit using the formula. Now, we all know speed is distance upon time. Now, distance is measured in meters and time is measured in seconds. So, unit of speed becomes meter per second. Velocity is equal to displacement upon time. So, your displacement is meter and time is second. So, the unit for speed and velocity is same, meter per second. What differ is when we measure the distance or displacement. Now we will find how there is a difference, how the difference arises. Let us now use the above formulae to find out Ranjit's velocity and speed when he goes to school as shown in the figure. You can see from A to B, the actual distance now traversed by Ranjit from home to school is first A to B, B to C and then C to D. That means 500 meters, 700 meters and 300 meters, which is going to be equal to 1500 meters. This is the distance travelled. Now the total time from home to school, 8 minutes, 11 minutes and 6 minutes, that is 25 minutes. Now we are going to calculate the displacement from home to school, that is AD, which is equal to 1000 meters. Thus Ranjit's velocity when going from home to school is equal to displacement upon total time, which is equal to 1000 upon 25. So that becomes 40 meters upon 60 seconds. 25 ones are 25, 40s are, and 1 minute is 60 seconds. So 0.66 meter per second. Ranjit's speed while going to school is distance traversed upon total time, which will be equal to 1500 meters upon 25 minutes, which is equal to 60 meters upon 60 seconds, and the speed is 1 meter per second. Now you can see here why velocity and speed are different. It is because in the formula of velocity displacement and in speed distance. Distance is basically Ranjit has gone from A to B, B to C and C to D. But in the end it has reached A from point A to point D. But since the path was traversed, it was called displacement. And distance is the minimum distance that it has been travelled. Now Ranjit did not take the straight route of minimum distance while going to school. Therefore, the magnitude of his velocity and speed came out to be different. Had Ranjit actually gone by straight route AD, then the magnitude of his velocity and speed would have been same. As we have seen the difference between speed and velocity, now we will further study average velocity and instantaneous velocity. First, we will study what is average velocity. Velocity of an object can change even if it is moving in a straight line. Suppose that a truck is covering a distance of 40 km from A to D in a straight line. That is, displacement will be 40 km. If it requires altogether 1 hour for this, the average velocity is 40 km per hour. However, if the truck is traversed the 10 km distance AB in 10 minutes, BC in 20 minutes and CD in 30 minutes, then velocity of distance AB in kilometer per hour, 10 kilometer upon 10 minutes. Now 10 minutes is the denominator. We need the velocity in kilometer per hour. So 10 minutes has to be made into 60 minutes so that it becomes 1 hour. Now when we multiply 10 multiplied by 6, we have to multiply 10 kilometer also with 6, and that is how we get 60 kilometer upon 60 minutes, which is equal to 60 km per hour. Now look at the velocity of for the distance BC in kilometer per hour. You can see 10 kilometer upon 20 minutes. Now again 20 minutes you have to make it as 60 minutes. So 20 multiply by 3. So 10 kilometer also multiply by 3. So it becomes 30 kilometer per hour. Same with 20 kilometer upon 30 minutes for velocity for the distance CD. It is 30 minutes, we have to make 60 minutes. So 40 kilometer upon 60 minutes is equal to 40 kilometer per hour. 60 minutes is equal to 1 hour. Hence 40 upon 1, which will be 40. Now deduce the velocity for the distances BC and CD. We see that the velocity of the truck is different in different segments of the road AB, BC and CD. However, average velocity for the entire route AD is 40 km per hour. Velocity for the distance AD in kilometer per hour is 40 km per hour. The velocity at a particular moment of time is called instantaneous velocity. The instantaneous velocity can be different at different times. As we have seen, velocity is instantaneous and average. Using velocity, we come to a further quantity which is called as acceleration. Now, change in velocity with respect to time is called acceleration. In the previous example, the truck covered the distance AB at the velocity of 60 km per hour, BC 30 km per hour and CD at 40 km per hour. Now, if you see, the velocity for the distance CD is greater than the velocity for the distance BC. From the number of seconds required for this change in velocity to take place, the change in velocity per second can be deduced. So this is called acceleration. Change in velocity with respect to time is called acceleration. Now, acceleration and velocity are dependent on each other. So what is the cause of acceleration? We now see that the truck driver increases or decreases the velocity of the truck by means of accelerator. You might have seen a toy car that runs on a clockwork spring. When it is released on a flat floor after winding up the spring, it goes in a straight line. However, when it is hit on one side, it changes the direction and keeps going. If it collides into a wall, it stops. It means that its velocity changes. How did this change take place? It happens because the car comes in contact with something external to it. On a football ground, how does the direction of the ball moving in a straight line change? Now, when we kick the ball, it is actually applying force. When it is being kicked, the direction is changing. When its direction changes, the velocity of the ball changes, and that is to say, an acceleration takes place. The interaction that brings about the acceleration is called force. When we apply force, acceleration is created. And hence we define acceleration as change in velocity. Force acts on a body. Now use your brain power and think. The unit of acceleration is meter per second square. How is it possible? We will verify this. Now your acceleration is change in velocity upon time taken for change. Now unit of velocity upon unit of time. We know that the unit of velocity is meter per second because velocity is displacement upon time and there is already a unit of time present. So meter upon second into second is equal to meter per second square. So the unit of acceleration is meter per second square. I hope I am clear with the concept of acceleration, velocity and speed. Thank you.